we are going to calculate the hydrostatic force that's acting on this semicircular plate, which is vertically into the water. How can we do that? So remember, force is equal to pressure times area, and area is something that we should start off first, because usually that's the harder part. And to do that, we draw a rectangle like this, and I will label this as dy, the small change in the vertical distance. And then we also need a reference frame, and it really depends on how you want to do it. But let me do it this way. I will look at the bottom of the semicircle as my x-axis. I will cut right in the middle. That will be the origin. And I will say this right here will be my x-axis, and then since I cut right in the middle, and I will just draw this right here to be my y-axis. And the good thing for me to do that is because now we know this part right here will be just the x value, and we need an equation relating the y and the x, because I'm going to integrate it over y in a minute. This is pretty much the circle. It's a semicircle, but then I just need to write an equation of the circle, and then we just have to be careful with the limits of integration. Then that will give us this part that we need. So we are here. That's the origin of the reference frame that we pick, but it's also the center of the circle, and that means we will have 0, 0. And we can just start off with an equation by saying x squared plus y squared is equal to, what's the radius? The whole thing right here, the diameter was 10. So from here to here, it will be 5 feet. So it will be 5 squared. So that's pretty much it. And I need x in terms of y, so let's do it. Let's subtract y squared on both sides. In another word, we have x squared equals to 5 squared, which is 25, minus y squared. And I'm going to take the positive square root of the positive square root on both sides, because based on the labeling, x is on the right hand side. It's positive. So I'll take the positive square root on both sides. X will be square root of 25 minus y squared. And we are ready to go, because for the area of this red rectangle, so I have x here, so I have 2x. Okay, so I'll put on 2 first, and then the x value, the expression, I'll say, it's right here. Square root of 25 minus y squared. And we multiply this by dy. And this will take care of the area. Okay, once again, sometimes you have to multiply by 2, sometimes not, depending if you have x and x, or maybe just one side. So in this case, we have 2x. So just be careful with this 2 or not. So area done. Now, which number do we use? Depending on the units, right? Feet. So we have to multiply by 62.5. So let's do that. 62.5. So no problems on that. Last part. Distance. How far down we are underneath the water. So based on labeling, from here to here, it will be the y. But then I want to figure out all the way. Well, this right here is the radius, which is 5. From here to here, I'm just talking about this part. This part will be 5 minus y, because from here to here, which is the radius, it should be 5. This much is y already, so this much right here, so I'm just saying this much right here, it will be 5 minus y. But then I have to add 2 more, because I'm 2 feet, right? This is 2 feet down the water. So the whole thing from here to here is 2 plus 5 and minus y, which is 7 minus y. And that's the distance that we have to use. So we multiply by 7 minus y. Okay? And we integrate. We begin with 0, y is equal to 0, up to y is equal to 5. And that will give us the semicircle, 0 to 5. And that will give us the total force. And if you work this out, this is approximately, if you work out everything, 11972, which you can write this just like the answer in the back of the book would like to write 1.2 times 10 to the 4th power. This is in the foot or feet, right? Something like that. What's the unit for the force? It's just going to be pound. And we are done. So that's it.